Sorry, I cannot be with you. Um, so I'm going to go through this rather quickly and give you some tips on filling in the slides and working on the assignment. You can fast forward and whatever you need to do. We're starting a mathematical unit for those of you who are sort of worried about math. We'll make it as easy as we can. And always try to have a format that's repeatable. So once you learn the format, it should work out pretty good. Here you can see that we have at the very bottom, we have a blue color highlight and another blue colored highlight, and the terms are the same. And then the red at the bottom again, terms are the same. And the green terms are the same. And what I've done is I've changed apples through dozens into kilograms by using what's called conversion factors. And conversion factors are just equalities. 1 dozen equals 12. A dozen ends up equaling 2 kilograms if you put it on a scale. In chemistry, we use a representative particle called moles, and it just makes up a whole bunch of stuff of atoms or ions or molecules. And consequently, we don't really ever talk about the number of particles. We always talk about moles. So a mole is actually related to weight. In the middle of the screen, you can see a black pile of carbon on a scale, and it weighs 12.011 grams. That happens to be the average atomic mass on the periodic table. And copper, similarly, has a mass on the scale of 6.3 times 63.546, and that's the average atomic mass on the periodic table. And so all we're going to do is we're going to say 1 mole of a substance is equal to the grams of the average atomic mass on the periodic table, regardless of what it is. And so today's learning is to work with that in this way. So we saw before that 12 grams of carbon is 1 mole, or 63 grams of copper is 1 mole. We could reword that and say 1 mole is equal to 12 grams or of carbon, or 1 mole is equal to 63.5 grams of copper. And so what we could do is we say that we have a ratio of 12 grams to 1 mole. So I'm looking at the table and I'm looking across the top column. And if I change the grams to 6 grams, that is half of the mass, then I also change the moles to half the moles. So I've changed sulfur from 32 grams to 1 mole to 8 grams to what ratio would that be? Now you can do this in your head. You could do it through cross multiplication, but for me, it's 8 divided by 32 is 1/4. So then I will multiply 1/4 times 1, the 1 mole, and I'll end up with a 1/4 mole here. So I will end up with a 1/4 mole, or 0.25 moles. Now, I have to undo that, so you can always go back because it's the video, because this is the master. What about oxygen? So we look over here. See, we have the values listed here. For oxygen, what would the gram number be? Well, if carbon is 12.0 or 12.01, and sulfur is 32.06 or 32.0, then oxygen has to be, your turn, you can do this, 16. Good. All right. Which means that if I change the 16 to 32, that is 16 is to 1 mole, then 32 is to how many moles? And then again, you fill this in. And that's it. We're really done. We're going to just talk briefly here that if I have a collection of atoms, a molecule, And here on the second row or box is H2SO4, and there's a picture of H2SO4 shown below with 4 oxygens in red, 2 white hydrogens, and a sulfur in between. And if I break that up into 4 oxygens, 1 sulfur, and 2 hydrogens, why, then I can do the same thing I did before, only I have to sum it. I have to take all these values and add them together. So I will find my mass of oxygen, which is pretty precise on this periodic table, and multiply it by 4 because I have 4 oxygens here. And I will add that to 1 of my sulfurs, and I will add that to 2 of my hydrogens. And when I put all those together, I end up with 38.072. So if we try that really fast, because I need to get to the next part of the lesson, we add all the pieces together, or I'm looking at the bottom where it's in blue. There are 2 oxygens, so instead of adding 2 oxygens, it is possible to multiply the 16.0 by 2 to get my new number. So we see that both blue on the left and blue in the first column on the right. Our job is to repeat that process of finding the number of the molar mass of each atom and then adding it together. So here's F. I'm in the second row for sulfur trifluoride. And I look over to the far right and I see it's 19. So I'm going to do 3 times 19 and say that's equal to 57. Let's see, 27, 57, yes. And then I got to add those together. So I'm going to do that over here. 32 plus 57 is equal to 89. And then we always use this unit, grams per mole. All right, so you can do the other 2. Now, the next worksheet we're going to do is a repeat of this. So you may not even have to go through all of the reading here, which shows you that we're doing the average atomic mass, and then we're changing it into grams per mole. So let's look here at sodium. We can see straight across from sodium is its periodic table cell, and it says the average atomic mass is 22.99, and therefore the grams per mole, or molar mass, is 22.99. And you can repeat that with carbon, which we saw in the slides. And then we have to add these together. So we have to pick out each one. Sodium, remember, was 22.99. And then we had a hydrogen, which is 1.01. It is. And then we have a carbon, and it's 12.01. And then we have 3 times 16. So oxygen 16.00. So now we need to combine those to find out what the sum is. So, hey Siri, what's 22.99 plus 1.01 plus 12.01 plus 3 times 16?
22.99 plus 1.01 plus 12.
No, it stopped. We're doing so well. Sorry, I took my phone out of my pocket. Hey Siri, what's 22.99 plus 1.01 plus 12.01 plus 48?
It's 84.01.
Okay, so over here we'd do 84.01. I multiplied 3 times 16 in my head because I didn't want to get the wrong answer. And here I'm going to finish doing the complete answer by writing grams per mole and the substance. All right, so down here we are going to do 2 examples of how to do problems. So the molar mass of 2 oxygens is 32.0. And the given amount is there in bold. It's 6.4 grams of oxygen. And the answer, we're trying to figure out moles. And so you'll notice this color coding. We need this top to be about moles, and we need this bottom to be about grams of oxygen. And this is going to be moles of oxygen. And this will be moles of oxygen. And that's supposed to be a little m. All right, so where do we get this number? Oh, we get this number up here. We figured out the molar mass, and the molar mass was 32.0 grams for each mole, for 1 mole. So what we're going to do is we're going to put 1 here, and we're going to put 32 here. And then the math is basically like regular math. We're going to multiply the top number and divide by the bottom. Now this arrangement of given, ratio, answer is what we're going to use every time. So I said at the beginning, this is a math heavy unit and you have to learn math, but it'll always look this way. Like it'll always look in, it'll be set up in this way to really guide you to the answer. All right. Hey Siri, it is 6.4 divided by 32.
6.4 divided by 32 is 0.2.
All right. So I multiplied the two numbers on top and got 6.4, and then I divided by the bottom number, 32. All right. So let's just write that here. So you have 6.4 divided by 32 equals, so that you know what's happening for here. All right, let's put these together. These are 22.99. We have 2 of them, and we're going to add 16 to that, and that will equal, and again, it's 1 mole. We only have 1 mole here. Okay. Hey Siri, what's 22.99 times 2 plus 16?
22.99 times 2 plus 16 is 61.98.
Okay, and we're going to use that. So let's see what we start with. This time we start with 0.5 moles of Na2O. Notice I dropped the word of. It shows up in the problem. It's not showing up when I do my math. Down here, we're going to use purple. It's blue. It's moles. And up here, we're using grams. And that's because our answer is supposed to be grams of Na2O. So it's like the apples and bushels at the beginning, except this time I've used the font color. Whatever I start with goes on the bottom. What I'm trying to get goes on top. And then I just go up here, and the mole will always be 1 whenever we're using grams. That was important, that we have to be using grams for this to be 1. And there we go. We just multiply the 2 top numbers this time, and we divide by 1. So 0.5 times 61.98 is going to equal, and 30.99 grams. All right. So there you go. That's what you're supposed to do. Some of it's pretty easy. You should work with each other, and you really only have a little bit to do. We can talk about this tomorrow. You need to be able to answer these questions. If you remember our last test, the multiple choice part often has things that have you reflect about what you're doing. And that's what this does. This reflects about what we were doing, and so you can always find that kind of work is really important in reinforcing what we learned. All right, well, please listen to this. Oh, I hope you listen to this video. I hope you have a good start, and I will see you on Tuesday. Thank you.